Okay, we want to find the angle between the force shown here and the line AO here. And the way we're going to do that is using a dot product, knowing that the dot product of that force with the position vector of AO becomes the magnitude of these multiplied together times the cosine of the angle between them. Okay, so again, F is given to us. We'll just go ahead and write that down. It's negative 6i plus 9j plus 3k. Let's find the magnitude of that force, because again, we're going to need that as well in order to find that angle, right? We need the dot product and the magnitude of each of these vectors, right? So that's going to be the square root of 6 squared plus 9 squared plus 3 squared. Okay, in doing that, I get a magnitude of 11.2. And again, this would be in kilonewtons, but again, our units aren't going to really matter. We can do any vectors we want, right? We could do 2 unit vectors, 2 force vectors, 2 position vectors, or any combination, a unit vector and a position vector, a force vector and a unit vector, whatever it might be, okay? So let's go ahead and do the position vector, which is going to be negative 1 in the I plus 2 in the J minus 2 in the K, and its magnitude is going to be the square root of 1 squared plus 2 squared plus 2 squared, which should be 3 if I'm not mistaken. Okay, so now let's go ahead and do the dot product. Okay, so we're going to dot these two vectors together. And what we do with the dot product is we multiply the i's together, the j's together, and the k's together, and then add them up. And again, what we get is just a scalar value. Okay, so we're going to take negative 6 times negative 1, right? Those are the two I values. Okay, keep track of your signs on this one. Okay, to that we're going to add 9 times 2, right? Those are the j's that I'm adding to, or multiplying together. And then I'm going to add to that my k's multiplied together, which will be 3 and negative 2, right? So it's going to be 6 plus 18 minus 6 gives me 18. And again, this dot product, unlike the cross product, this dot product actually gives me just a scalar value. Okay, it's not, I don't get a vector back. So from this, I'm going to use that top equation and solve for theta, which is what I'm trying to do, which is going to be the inverse cosine, okay, of that dot product, 18, divided by the two magnitudes multiplied together, which will be 11.2 and 3. Okay, so again, any two types of vectors will work on this. I used a force and a position vector here, but they can be any combination of vectors that you want. Okay, and you just do an inverse cosine of that dot product divided by the magnitudes multiplied together. And from that, I get an angle of 57.7 degrees. And that's that direct three-dimensional angle between those two vectors using the dot product.